of two linked lists. It is given the heads of two singly linked lists, head A and head B. We need to return the node at which the two links intersect. If the two linked lists have no intersection at all, we need to return null. Okay, so it is given two lists. We need to find the intersection. If there is no intersection, we need to return null. You can read about details how they were text. And it is a symbol, and then they are asking to write the solution that runs order of m plus n and time complexity. And then for the memory, we need to use the order of 1. It's okay that this one is to optimize our solution. I will go with two ideas. The first one is simple one, and then the second one is optimized one. The first idea is we will go through the first links, and then I will put the nodes in a list, and then I will go through the list to second list, and then I will check each node is already in our list. If there is something which already in the list, we will consume. I will assume that it is intersection. So I will go through that idea first. I will make a index node like head A, list node B equal head B, and then I will create a list of list nodes and A to make memory to save which nodes are in nodes A, list A. Okay, while node A not equal null, I will put that node values in my list, and then I will move to the next node. And then after that, I will go through the node B. I will check each node is already in our list. If it is already included, I will return that node B. If it is not, I will move to the another node in the linked list B. Okay, and then if we cannot find at all, we will return null value. I'm gonna run this code. This is cool. Okay, but when we are looking at the time complexity and speed complexity, time complexity, this one is order of if the sorry, if the length of the linked list A is n, and then the length of the linked list B is m, we will have order of n plus m squared, and because this one is order of m plus nm, I think, because this one is already we need to loop that again, right? So this one is time. If we look at the time complexity, is kind of a little bit higher than what we want. Okay, but if it is coming with a memory, it is really different from what we need. Here is we are using links, so this one is order of n or order of m, depending on what we think, right? Okay, so what we want right now, I'm creating the list depending on the list A. So it will be the numbers of nodes in the linked list A, right? So now the memory is really different from what we want, because we want only one or constant memory. So we cannot use those kind of list collection, or so we cannot use this one. But the idea is okay, but it cannot be the best solution. So I will go with another idea. Another idea is we will look at this one, A1, A2, C1, C2, C3. If we compare those two lists, if we have intersection, the very last notes will be the same. So we can ignore the elements, extra elements. Now B1. If the list A have 5 notes, if the list B has 6 notes, the difference is 1. At the time, we will ignore 1 note from the longer list, right? So we have to go through the list A. We will get the length of the list A. We will go through the list B. We will get the length of the list B. We will get the difference between those lengths, and then the difference is 1. At the time, we will step at the 1, the note at the 1. Now we step this one. If the note A has 1, we need to jump to the another note because the difference is 1. If the difference is 2, we need to jump 2 times to compare with the first element from the list A. So at the time, we need to go list 1 again. We need to go through the list 2, and then we need to compare those again. So we need 3 loops, right? So it's not being the best one. It's still not optimized. So how will we do that? So to complete everything in a one loop, we can go this way. We will go through by using the list index like this, node A and then node B. Node A, we will start this one. Node B, we will start from this one, and then we will go this one. If the node A is being null, we will go to the list B. At the time, node A will be here, and then node B is still here because the length of the list B is longer than that, right? Okay, at the time when the node A is here, the node B is still here. When the node B is null, node B should go to the list A. At the time the node A is jumped to the another node, at the time node A here, node B will be the same to compare. Will be the same level. We will compare here, we will compare here, and then we will compare here. When they meet, when they are intersect, if they are equal, we can return that nodes. If they are not equal, we will go through till both of them are null. If both of them are null, we will return the null value, right? Okay, so I'll go this one. I will go with that idea. That is the same. We will make this one is like a index node, and then y node A not equal, whatever it is, they will reach at null value in the same time, right? So node B, if until they are not equal, we will go through. If they are equal, it is null value, right? We can return anything we want. We will go through node A equal. If the node A is equal null, that means node A is null. We will if node A is null, we will go with the head B. If it is not, node A dominates. Node B equal. If it is node B is null, we will go with the head A, and we will go with the node B with null, with node B next node if it is not null. And then by going that way, we can reach to the null value if there is no intersection. Okay, I'm gonna run this one. Oh, here, what happened to this if no A equal? Oh, I'm sorry. Here, this one is in SQL or something. I made a mistake. Sorry. Okay, now I'm gonna submit this one. Okay, cool. So you can see the difference, time complexity, and the memory is not too much difference, but this one is because the text values are short, right? The tags are like like this, if the memory is big, the link list, if when the link lists are bigger and bigger, the memory will be big difference. So now we can see too much different in the runtime, and then now our optimized solution is 99.2% faster than that. So it's really good and it is optimized, but we can still do this way too. It's still okay. We just got the optimized one. Thank you.